Hello everybody, this is Dr. Thunder. Today, I would like to show you how to solve a US high school physics competition question. So, an arrow is launched from the ground, so it passes through two loops, which are both a height of h above the ground. So this is h, from here to here is h. So the arrow passes through the first loop 1 second after the arrow is launched. So this from here to here is 1 second. And then it goes up and stop and then fall back through the second loop. And so from first loop to the second loop, it's also a second. So we want to calculate what is the value of h. This is a relatively simple question, but we need quite some calculations. So we define some terms first. So we already have h here. So and then it takes 1 second from here to reach the height of h. And then at some moment the arrow will stop. So from the first loop to the top point, we define the distance as h prime, and then the time it takes for the arrow to go from the first loop to the top point will be t1. Then the arrow will fall down. So again, from the top point to the second loop, the distance is h prime, and then the time it takes is t2. And of course, here is also h from the second loop to the ground. And then the arrow is launched at the initial speed of VO. Of course, there's no resistance from the air. So when the arrow falls to the ground, the speed is also V0 or VO. So now let's write some equations. So first one is h plus h prime. So from here to here, so we have v0 t1 plus 1. The total time is t1 and 1 second, minus half g t1 plus 1 square. This is a very common equation. So that's equal to v0 t1 plus 1. So g we can take 10, so it becomes 5 t1 plus 1. So we this is equation 1. So here we use the SI unit. So the second equation, we go from the arrow drop. So h prime is drop from here to here, because at this moment the speed is zero. So h prime is 0. We do not write 0 here. So it's half g t2 square, t2. So g is 10, so it's 5 t2 square. So this is equation 2. And then we know that the arrow goes through the first loop and then go through the second loop. The time is t1 plus t2. t1 plus t2, we know is 1 second. So that's equation 3. Now let's look at this part, h. So when the arrow goes from the ground to the first loop, the distance is h and the time it takes is 1 second. So h is v0 multiplied by 1, because there's only 1 second. Then minus half g 1 second t. So that equal to v0 minus 5. So that's equation 4. Now let's look at this process again. So you know the arrow goes from v0 to v equal to 0 here. So 0 is v0 minus g t1 plus 1. Okay, g is a gravitational acceleration, and then it takes 1 second plus t1 to reach the top, and at this moment the speed is 0. So so we can deduct that v0 is g is 10 t1 plus 1. So that further deduct t1 is we have to because here h is equal to v0 minus 5, so v0 is h plus 5. So so we get t1 is h minus 5 divided by 10. Okay, so I omit the detail process, but the result is t1 is h minus 5 divided by 10. So that's equation 5. It's not difficult to deduct these results. Remember, we have to put v0 is h plus 5 here, and then calculate t1 is like that. Now this is so now we look at this equation. So we know h prime is this number, right? And then so we rewrite this equation, so it becomes h plus 5t2 squared equal to h plus 5 t1 plus 1 minus 5 t1 plus 1. So we plug equation 3 here, then it becomes h plus 5 1 minus t1 square, that equal to h plus 5 minus 10 t1 plus 5 t1 square, that equal to this term. This term is h t1 plus h plus 5 t1 plus 5 minus 5 t1 square minus 10 t1 minus 5. So that show the results. 10 t1 square equal to h t1 plus 5 t1 minus 5. That's h plus 5 t1 minus 5. Then we plug equation 5 here. Then we get equation 5 is 10 h minus 5 100 equal to put t1 here, so t1 h squared minus 25 10 and minus 5. It's kind of complex. So then we have h minus 5 squared equal to h squared 25 minus 50. That give you h squared 10h squared. So remove h squared here. Then we get 10h is 10h is 100, so we get h is 10 and the unit is meter because we use SI unit all the way. Now this is pretty complex, so we have a quick and dirty method. So here we have a quick and dirty method. So we know that when it goes through the first loop and then it reaches the top, it takes T1, and then they draw and then go through the second loop, it takes T2. We know that T1 plus T2 is 1 second. So we give a ball guess here. T1 is equal to T2. So T1 equal to T2, that's a half second. Now we plug this into 5. So plug into equation 5 here. So 0.5 is h minus 510. So that gives us h is 10 meter. So this is a quick and dirty method. We get the same answer, but much quicker. You know, in this kind of competition, time is everything. So we may use this method instead. So thank you for viewing. If you like my video, please comment, like, and subscribe.